This is a presentation from the San Francisco Bay Area chapter of the ACM, and we have been in operation in one form or another for about 70 years. We put on 2 technical talks free to the public every month, generally. One on the 3rd Wednesday of the month, which is a general computing talk, and one on the 4th Monday of the month, which is a data science type talk. We have a YouTube channel, and people can see our upcoming events, which I'm sharing up now. So, for example, we are also advertising some events from the Silicon Valley Engineering Council, February 24th. There is an event that they are putting on, so please look at that on our meetup page. Then on February 27th, we have nanobody optimization via machine learning, which is a presentation by actually a very advanced high school student who has won awards at various science fairs for his work on this subject. Then we have a professional development seminar coming up on March 11th and 12th. That's a Saturday and Sunday. Scaling computer vision workloads with Ray. And this is a workshop. It's an in-person event that will either be held at Hacker Dojo in Mountain View or at Palo Alto Networks. And so we have in our text on Meetup, there is a link to an Eventbrite page to sign up for that. That is not a free event, as opposed to our normal twice a month public talks. Let me just introduce our speaker here, Ankur Patel, who leads growth for identity at Microsoft, and perhaps he can tell us more about what that means in a bit. You know, Ankur, could you talk a little bit for a moment as an intro about what you're doing in general?
Sure. Hopefully everyone can hear me okay. Looks like we're a small group, so I can keep an eye on the chat, or you're welcome to come off mute or whatever the protocol is. My name is Ankur Patel. I'm a product manager. I lead product development for Entra-Verified ID. My role on the team, however, is about finding growth opportunities for identity systems at Microsoft. So identity at Microsoft covers our consumer-facing identity system, which is how you do Xbox, Windows, Outlook, or any of our consumer products, basically. There is billions of users of that. Our team also does enterprise identity systems, which is Azure Active Directory. Hundreds of thousands of businesses around the world run on Azure Active Directory, many governments, including one in America and the United Nations for that matter. So we perform identity and access management solutions for them in the cloud. Anybody who uses Office basically uses Azure Active Directory. And then there is LinkedIn, which is an acquisition we did around the professional identity system. So we have consumers, professionals, and then at work. All 3 audiences their interface to applications is through our identity system. And my role on this team now is about what's next. So a decade ago, that was taking Active Directory to the cloud. Then it was connecting the graph for enterprise and consumer identities to LinkedIn. And most recently, I've been working around decentralized identity and verifiable credentials. And we think this is a way that we can improve trustworthiness beyond possession of a username and password. So I'm thrilled to talk to you guys more about it.
Okay. Well, why don't you go ahead and Are you prepared to start your talk?
Sure.
Okay, well,
I'll share my screen.
let's do that.
There you go. Hopefully you guys can see that okay. And your invite had the timing mixed up. So is it half hour or so you want me to spend on it?
You're welcome to spend, a little bit more, 45 minutes if you've got.
So we can spend time with Q&A as well. So for the audience, I'll keep the chat window open on the side. If you have questions, please ask me. And since, again, it's a small group, if you can indicate more technical, more business, let me know so I can appropriately cover the altitude of the conversation. Okay, so let's first talk about why do we need this thing and what is Entra-Verified ID. So Entra-Verified ID is our umbrella brand called Entra, which includes Azure Active Directory, our cross-cloud permissions management in the enterprise space, and then the latest one is Verified ID. And the purpose of this is current identity systems are very domain specific or domain bound. So if you have a username and password, it works for that domain. And then you have to federate or connect apps to authenticate or authorize against it. But it results in a lot of security and compliance and privacy issues on tracking and correlating things, which is not always desired, especially for some of the scenarios where you want to be able to present a credential to anyone on the internet. So we think this is a better way to do so. So the idea here is, instead of thinking about the world as accounts, what if we think about it as attestations that a user can present? For example, Xbox can tell you your gaming achievements, and your education institution can tell you your education credentials, and your bank can talk about how much money you have, and hospitals can tell you health. In fact, all of these attributes put together make up our true digital identity, which is greater than accounts, therefore, that each of these subsystems present. So the goal of Verified ID is to enable you to connect all these attributes under the user's control, and they can choose to disclose as much or as little as they see fit. All of this work, as a result, is based on open standards. Verified ID itself is a reference implementation of said open standards. So I'll cover some more details on those standards as we get going. So what problem is it solving? As the title of the talk says, it's one of the key scenarios we have found our customers using this technology for is for reducing friction and improving trustworthiness at time of onboarding new users. Those users could be employees, could be contractors, could be customers, like business to consumer kind of thing. Because today, when we spend so much time doing that initial onboarding work, and this is not particularly true for consumer apps, right? Where most consumer apps will deal with fraud after the fact. They want least friction possible. However, when you're entering higher compliance processes, you need to verify information. So we today collect a bunch of information manually or through a third party. By the end of the process, we issue usernames and passwords. And that's how we access all these resources. The challenge with that is possession equals entitlement. Anybody could have a username and password, and they could show up on this call, for example, with a made up name, and you wouldn't know who you're actually talking to, as I don't know who I'm talking to today. It gets worse when we talk about recovery of that account. So if you lose that username and password, typically you ask for an email round trip or SMS text or a knowledge-based question, which is terrible, right? Like, I think we can Google and find out what street people grew up on. So it's not particularly good posture. As a result, 82% of our customers point out they want a safer, faster, and easier way of doing these things. So when we collect this kind of information, such as people's selfies or government-issued identity documents, etc., it results in yet further risk to the enterprise as bad guys try to break in to get access to such information. Second, you need to end up doing custom integrations for doing such verifications. Many of, I don't know, again, your background, but if you've set up integrations with sign in with Facebook or Google or third-party websites like Stripe, then each one of them is a custom integration. you still end up holding a bunch of personally identifiable information, which you may or may not want to do as an enterprise. And the wait time for doing that verification is non-deterministic. If you do end up going with least common denominator, like a social sign-in, you're basically outsourcing the access to your business to Facebook or Google to decide whether you will be in business or not, because they can turn that off. And then finally, the last step is the cost of all of this, cost of building it, cost of cognitive load for normal people to understand how all this stuff works. I don't know if the people in the audience here, sounds like most of you might be from US, America, but like in Europe, there is general data protection, GDPR. You may be working with customers of yours who are over there, which helps after the fact, like your data has been collected. If you want to find out what data was collected, hopefully you can find the button on the website, if you remember all the websites. And then if you get all the data out, hopefully the data makes sense to you, because most of the time the data is encoded in some form. And then finally, hope that data is accurate and complete, right? So it's not particularly easy for people to keep track of their information and create lots of different usernames and passwords and so on and so forth. In contrast to using, I don't know, cards that are in our wallet, like a credit card or a driver's license, where you can put it in any wallet you like, you can use it in many places, the same credential works everywhere, there's a good recovery process that goes with it, etc. So as a community, we've been working in Decentralized Identity Foundation to imagine an alternate experience where you can verify information once and use it everywhere. I can show you a quick demonstration of what that would look like. I'll just pause here and see if anybody has any questions or comments. Oh, there's a question. Anonymous attendee. Hi. Would you be reliant on Microsoft as you would like mentioned on Google or Facebook or Entra-Verified IDs from Microsoft? No, because in the next slide, I'll show you the open standards that we've done a reference implementation of. So you can choose to use your own open source implementation of it to issue, request, verify, or revoke a credential, irrespective of whether they used a Microsoft infrastructure to manage that lifecycle to begin with or somebody else's. Okay. Okay. Hopefully that helps answer the question. And again, I'll provide you more evidence as we get going. So this demonstration website is available to you as well. So if you have Microsoft Authenticator, for example, you can use it to start the demo, but I can walk you through it for now. So the setup. Woodgrove is a fictitious enterprise company. They want to hire someone. So they send them an email link or they showed up in person. And they're self-attesting. I'm Matthew Michael. When you click next, the company says, welcome, Matthew, but we don't know you. The first step is we need to get you verified. So in this case, they have partnered with a fictitious company called True Identity, Inc. And this is a trust ceremony now. You could do this ceremony in person, or you can choose to collect information digitally. So in this case, Matthew Michael self-attests the name, takes a selfie, uploads a government-issued identity document. If you've done anything related to cryptocurrency in recent times or done any banking related know your customer flows in recent times during COVID, you've done a flow like this, where vendors like these are able to verify the selfie for liveness. They're able to verify the integrity of the government issued document. They're able to match the selfie to the document to make sure you are the right person. But instead of sharing that data on the back channel, in the verifiable credential world, that information is shared by issuing that attestation to the user. So let me bring up my phone to show you what the end user experience could be. So if I click OK, it generates a request here. I'll put this to the side and I'll bring up my phone. Okay, so let's bring this here. So in our case, we have extended Microsoft Authenticator, which holds your multi-factor authentication credentials or passwords, to now also hold verified IDs. So I'll just reset my demo, delete these two cards real quick. So I can go scan this QR code. And the reason I'm doing a scanning of a QR code is because I'm demonstrating this across 2 devices for convenience. But if I was doing my entire demo on my phone, I would have just clicked the link and it would have launched Authenticator. Now here, if you notice, True Identity Inc. is issuing me a signed credential. And if I tap on that credential, it will show a bunch of details about the card, right? I don't know why it's taking so long. Is it taking so long though? Oops, something went wrong, of course. Let's try that again. Demo gods, as always, right? Doesn't matter if you've done it for several years or doing it for the first time. 4728.
The joys of live presentation.
There you go. Exactly. So in this case, I have a True Identity and credential signed by them with a bunch of attributes. In this case, they verified my selfie, address, whatever information Woodgrove, my employer, needed to complete this flow. So I can now go and say, hey, I've verified with them. I have a card like this. I can present it to you. So in this case, I scan that QR code and now I'm presenting this credential. This request is just OpenID Connect. Just like you ask for username and password, but instead you can now ask for a verifiable credential. This is the power of open standards and a whole bunch of people around the world working on it, not Microsoft alone. And we just, again, have a managed implementation of it. In this case, Woodgrove can now trust the signature. It came from the partner that they have business dealings with. It has the information they need to onboard me. Furthermore, since this is my first day at the job, instead of giving me username and password again, they can issue me a workplace credential. So in this case, I now have a second credential. I'm a verified employee of Woodgrove. It has my address, title, whatever. I can not only use this credential at work, but beyond work. So ProSwear is an online reseller of computer equipment. They provide discounts to companies they have partnerships with. Typically, you set up these federations. Now imagine if such a retailer wants to provide discount to any Fortune 500 company. How many federations can you set up? Versus, in this case, you can ask me for a credential of type verified employee. And if my employer is on your list, I get my discount. And best of all, if I go to the activity tab for this credential, I have a cryptographically signed receipt in my pocket as a user that I can keep track of exactly what credential I shared with whom and for what purpose, locally under my thumb, as opposed to you granted consent to someone for some purpose and who knows what happened with that information later. So to summarize, we believe this information is not only easy to use and secure, just like multi-factor authentication, but it's more verifiable because you can now directly go to the authoritative source, not a third party or a delegate identity system in the middle. You're directly going to, in this case, Woodgrove. So a bookstore can check directly with Woodgrove, hey, are you an employee of this company? The user has greater transparency on exactly what attributes are being shared and for what purpose. It can only be shared with their thumb on the phone. And then finally, they have a convenient way of keeping track of all of these interactions. And most importantly, it is predictable. All interactions across all websites or apps, irrespective of who the issuer is and who the verifier is, become consistent. I'll stop here and see if you have any questions before I go under the hood as to how it works. Did the scenario walkthrough make sense? Anybody have any questions or comments? Okay, I'll assume silence equals we're golden. So we think such credentials can help power the trust fabric for the internet. So if you notice, like that workplace credential, imagine if you're a student. If you had a verified student ID card and you want to continue your education, today you have to create another username and password. Instead, you can now present that student credential or alumni credential to continue your education. You can choose to go to a bank and get a student checking account. You can choose to apply for an internship. You can choose to get verified on LinkedIn. You may choose to get a retail discount. All of these scenarios are consistent and predictable. So this becomes a truly internet-facing credential versus a username and password, which only works in your own little bubble, one app, if you will. or 5 if you set up partnerships. So how does it work? So first thing to notice in this picture, the logical way would be an issuer issues a card to a user who presents it to a verifier or an app. This is very different than the way our current account-based identity systems work. The accurate way to show the current account-based identity systems would be the issuer is in the middle. The user is on one side and the app in the other. So the user grants consent to an identity provider like Facebook or Google or Microsoft, and it shares information on your behalf to the verifier. Versus in this world, if you notice, the issuer can sign a credential using a cryptographic key that is independently held by them against another cryptographic key, this one, that is held by the user. An application can now request this credential directly without coordinating with the issuer. As a result, the issuer has no idea on where this credential is being used, and they don't need to, unless it is inside a work boundary, right? What you do want is integrity to ensure that the verifier can say that it has not been tampered, so it is signed by the issuer. And the second one is a subject. The student is the only one who's presenting this credential and no one else can. Let me read Prakash's comment. Allowing the retailer to verify Woodgrove's employment on the customer. Is that controlled by Woodgrove Enterprise, or does the customer have the credential with them and they can authenticate without? Prakash, that's the point. It's the latter. In this case, ProSwear, the verifier, can authenticate directly with the user the proof of employment. And Woodgrove, the issuer, can revoke this credential at any time. And the state of that credential is on a certificate revocation list, again, unauthenticated. As a result, it reduces correlation from a verifier perspective and an issuer perspective. Does that make sense? Now, the state of that key is where these decentralized systems come into play. There are 100, last I checked, there's more than 100 methods that are registered with W3C on it. The heart of this system is this one innocuous thing called DID://. It's a recommended standard now, ratified by W3C last fall. I don't know if you guys are familiar with it, but it's the first base protocol W3C has ratified since HTTP. So it's a pretty big deal. Just like HTTP is an identifier for every web server and web page, DID is meant to be an identifier for everyone and everything in the world, right? And as a result, there is a unique DID that Woodgrove, the issuer, has. They can choose to anchor it on a web server or a blockchain type system. As I mentioned, there's more than 100 different methods. One other piece of technology in that open standard stack is called a universal resolver, which resolves across all those namespaces. So you could be on a Bitcoin-based blockchain or Ethereum or a web server, and an app doesn't need to understand any of it, so long as you're able to call the correct resolver. So Microsoft today supports DID Web and DID Ion. DID Web is available in production, DID Ion is available as preview. The entirety of the stack, there's lots more technical detail in it that's available at this link that we interoperate with other partners on, such as IBM, Workday, etc.
Ankur, I see a couple of questions.
Yeah,
in Q&A.
let me address them. Thank you.
You're welcome.
So to answer Cool's comment first, it is not almost, but it is. It's a private public key infrastructure. One key difference, however, is the resolution of that state of those keys. One of the problems we've had in traditional PKI system is, how do I find who has what keys and when those keys change? So in this world, we're using these blockchain or web server type systems to discover the latest state of such keys. Hopefully that makes sense. And then Jim's question on how does one deal with revocation? So one of the pieces of standards in this stack is called a status list. So every credential has its own revocation endpoint in it. So when a application receives that credential, they can check on that certificate revocation list if this particular credential has been revoked. And that can be managed by an issuer anytime they want. And because it's an unauthenticated endpoint, the issuer still has no insight into who checked the revocation status, which is a good thing from a privacy perspective. And if you want strongly correlated stuff, then you should continue to use contemporary account-based systems. Does that help answer questions for Jim and Cool, both of you guys? Good? I'll assume yes. Okay, cool. There's a bunch of other technology stuff that goes on. The stack is pretty far and wide and deep. Again, hundreds of really smart people have contributed over 5 years of their time in working through W3C process and through Decentralized Identity Foundation, where these ideas are born initially, and then ratified in places like W3C and OpenID Foundation. So thank you if anybody is on the call from those working groups. This has been super valuable to our customers. So I'll keep going forward. The enterprise experience for this, which is a managed version of these standards that we provide as part of Entra, is something like this. If you go to Azure portal, you would be able to issue a verified employee credential by default or create a custom credential. If you create a custom credential, you're able to configure the look and feel of that card, like I was showing you, the title, etc., logo. But you're also able to choose what proof must be provided. And the proof could be self-attested, as in fill out a form. It could be an ID token or access token from your existing identity systems. As a result, you can issue credentials against any identity system. You could be on AWS, Google, on-premises, Ping, Okta, whatever. Right? So long as you speak OpenID Connect, which is what the standards protocol requires. If you do that, then you would be able to show up in this list where we have a verified ID network, which says, who is an issuer? So if I want to accept a credential from Woodgrove, what credentials do they issue? These. So you're able to select one of those, and you can say, yep, I want to verify employee. These are the attributes I'm going to get from them. In addition, we have set up partnerships with identity verification companies who are able to verify attributes like, for example, if you're all from US, you might be familiar with Clear at the airport. So they are able to verify your biometrics and your government issue identity document. Someone like LexisNexis is able to verify that you're a legitimate organization with your legal entity and all of that, and so on and so forth. So across these partners, they are able to cover the world and provide ID verification. So you can get it directly from a source like a company or go to a partner like them. In addition, we have set up partnerships with system integration partners and value-add resellers who build custom solutions to help with vendor management, employee onboarding, building consumer solutions, etc. One additional thing we're building is part of governance. So if, again, this audience is familiar with identity access management, one of the things you can do is imagine if you have a guest user who comes to your company and wants to access a file, you can now say, hey, I need to know that you are really this person, as opposed to just you have an email string that invited you to access a file, and have them more strongly verified by whatever attributes you want to verify. So the platform is made up of the admin experience that I was just showing you, or you can just choose to use APIs. There's only 6 of them, and request and verify any credential and manage lifecycle. So the system itself is stateless. We don't store any of these credentials or data in Azure. It's sitting with the user in their wallet or in your data store as an issuer or a verifier. And the final piece of the puzzle we provide is this end user wallet type capability in Microsoft Authenticator, but it's also an open source SDK, so you can choose to build that into your own app. So you don't have to use Microsoft Authenticator. So a lot of our customers use this platform where Microsoft brand is not visible at all. They're just using a set of APIs to manage the experience.
So Ankur,
yeah,
you mentioned set of partners that y'all partnered with and your customers. Is this actually in use today?
Yeah, so this is in production as of August last year. And customers are using it for these scenarios that I've listed on the screen. It's for remote onboarding. It's for securing access to apps. So imagine like a Zoom call like this one. And you wanted to make sure that people were a member of the ACM chapter and not just somebody who got a random link to join, for example. You could choose to ask them for, give me a verified ID credential signed by ACM, for example. You can imagine such things are important for corporate scenarios where you want to make sure people joining in are from the right place. Account recovery, I don't know if you're familiar with it, but when we call help desk and ask to reset our password, on average, a help desk phone call is $50 in cost. Now imagine instead being able to say, do it self-service. Please verify your government issued identity document and your biometrics, and just the same way that I onboarded you, I can help you recover. Significantly cheaper. Both time, money, effort, compliance, all of that. And there's a bunch of customers building custom solutions ranging from verifying membership for labor unions and access to job sites like physical access, to metro services and citizen services and government fraud, and unemployment related stuff, mobile driver's licenses. There's an ISO working group looking at it. There's countless scenarios underway. I'll skip that journey in the interest of time, right? So you can choose, you can imagine each of these steps have attributes to be collected and verified. Imagine your 401k experience or working with a bank or whatever. All these places where we end up filling out manual paperwork and going through proxies. Imagine being able to do this work directly. Securing access to apps, as I mentioned. Not only can I verify your true identity, but imagine you can ask for certifications. The ACM one is one, but are you a data scientist? Did you do this Coursera thing, for example? And so on and so forth. Recovery, we already covered. So we have found customers find this as a cheaper, faster, more trustworthy way to do these kinds of flows, which are current bread and butter. And given current economic environment, a lot of customers are looking for being able to do these things in a cheaper, faster, and most trustworthy way. There's a bunch of customer case studies that are public. Bill, for your question, right? So this is in production and a lot of customers are doing lots of different things with it. So Department of Education in UK is using it to keep track of students and is the aid reaching all the right students. Credivera is using for that labor union part. Condatis and NHS are using it for staff mobility for doctors as they go to multiple hospitals. And how do we avoid having people create different usernames and passwords for everything? Government of Belgium is using it for helping people open businesses faster. Keio University in Japan is using it for student access to services. RMIT in Australia is using it for access to services on campus and off campus. That's some examples. And these case studies are public on the website that's available. So some of our next steps are, we want to continue to make the developer experience, the end user experience easier. We feel like we've done a pretty good job on registration, key management, interoperability. We need to do better on recovery and revocation. We want to do some more advanced scenario like selective disclosure or zero knowledge proof. So for example, when you hand over the credential today, you're handing the whole credential. But maybe in some scenarios, the most common example people use is a driver's license and being able to share just the fact that you're older than 21 and not have to hand over the entire license. Those are some of the properties of selective disclosure and zero knowledge proof. So we're working with the standards community on developing interoperability so that it works everywhere, including Microsoft products. Performance and scale, we currently support DidWeb and DidION is in public preview. We're exploring other methods to support based on customer feedback. And then finally, I always ask people who are interested in this topic to join and collaborate through DIF. Hundreds of companies are part of it. We are one of them. If this kind of scenarios and space seems interesting to you, that's a worthwhile place to come join.
And what is DIF again?
DIF stands for Decentralized Identity Foundation. That's where all those companies come together and explore ideas and come up with first prototypes and working prototypes for these things. And then once we agree on an approach, then we go to standards bodies like W3C or OpenID Foundation or FIDO Alliance or wherever, depending on which part of the stack we're talking about, to get things standardized.
So this seems like it could have potential to help prevent some of the identity theft that occurs today.
Yeah, that is the theory. Yeah. And other more scary things.
Well, one of the ways that identity theft happens, of course, is that scammers trick people into giving access to their accounts.
Right.
Is there something in this that will help with that?
So, for example, if I go back to the original screen, there's a bunch of cryptography in here that goes on behind the scenes. So, for example, in order for you to issue a request or verify these kinds of credentials, like the Contoso bookstore with this verified stamp, on the Microsoft side, when we do it, not only is there an SSL certificate, but we protect a whole bunch of businesses with 1.7 terabytes of data that gets generated through all kinds of digital signals. We do 130 billion daily authentication events. So we kind of know which apps are good and which ones are bad. And those signals are baked into these kinds of flows to prevent against it. One data point for it would be if you were to go buy an account from a Microsoft system on dark web, it is the cheapest compared to a Facebook or Google account. And the reason is our system detects a phished account or a hacked account faster than anybody else by using these kinds of signals. So we are building such preventions directly into these experiences. And that's a value add of why use Microsoft's implementation of open standards.
Okay.
Okay. Some of the resources for you guys to consider offline, and I'll send you a version of this doc through Bill and Company. This is the Decentralized Identity Foundation. This is their website where these ideas are born. This is our white paper from Microsoft on our North Star and our ambition of how we want to use these technologies and our roadmap, if you will. Did explain is a quick 3-minute video without any technology jargon describing why is this interesting, what is it for, etc. Links 4 and 5 are more for details on technology, how to implement it, how to verify it, how to use these samples and all that. Link 6 is blogs on topics like performance, scale, recovery. VC Interrupt profile is if you want to come implement open source version of this stuff, here's a profile that you can go implement as well. And the demo website is the one that I showed you. Prakash has another question. Does the identity trust the bookstore in this example primarily be based on standard certificate, or does the bookstore also have a credential to exchange with the person being authenticated? So Prakash, that verified checkmark I was showing you under the name of the bookstore is in a sense their credential. So it's their cryptographic key bound to their SSL certificate. In more advanced flows, customers can choose to ask for credentials like, hey, what's your Dun & Bradstreet number, for example, or other credentials as you were calling out. So both are possible. Out of the box, it's their public-private key pair bound to an SSL certificate. So root of trust is a web domain, just like all the rest of e-commerce today in the world. But customers can go farther and attach additional credentials if they want to. Cool. So that was my last slide. Hopefully that gives you guys a quick, good overview. There's one more question from Liana. Post your slides online for us to review. Yes, I will email it to you guys or tell me where you want me to upload it and I'll upload it there.
Yeah, if you like, you can, if it's online, you could post a link in the comments to the meetup that is, if you send us a link.
Sounds good. So the best place to go to get started with everything that I just shared is Verify Once. So this link should get you the case studies, developer documentation, all of the content I have covered.
Is this the one that says VC details?
It's this website. Okay, so it includes how to get started, the white paper, the announcement, the case studies, the partnerships, how the system works, the flows, the developer docs, analyst reports, all of it.
And was that one of the links that you had in that slide?
Yeah.
Okay.
And all the other resources are also discoverable just off here. Anonymous attendee is asking, how again do you know your information won't go to anyone? You can't, because in this case, as soon as you give data to someone, they have it and they can pass it on. However, what you have is a cryptographic receipt that says, I granted permission to, I don't know, the bookstore app for this purpose. And if it shows up anywhere else, then you would know you didn't intend to share it. There are protections against such things in Europe, not so much in America. But they are also considering such things such as CCPA in California for that matter. Now, go forward, one of the tips we mentioned, things like zero knowledge proof or selective disclosure would allow you to disclose minimal information. So even if the information was shared, it would be a Boolean that said, yep, older than 18, but no personal information that could be correlated to you.
Okay, let's see. Oh, one more here.
Has one more. Would be nice if every share of PII is authenticatable with the source of the PII. Yeah, in fact, that's what it is, Prakash, because when you request that information, you're not just asking for PII, you're asking for as verified by who? Your employer, your hospital, your government, or whoever. So in this world, there is very little that is self-attested. Now, you can choose to ask for self-attested things like, do you like white, dark mode or light mode? What font size do you like? Those things could be self-attested.
Okay. And again, you had given us a link to a demo that we could go through.
Yep, that's also in there.
Yeah.
And I can paste in, since again, it's a small group, I can go paste in all the links in the chat itself as a comment. So if people want it, they have it there as well. Was this useful? It's difficult to tell in this mode if this is landing for you guys or not. Or
I think it is. You know, you've given these links to a lot of information, and I think you've made people aware of something that a lot of us probably were not aware of, especially the extent to which it's going on.
Sure. Alan, thanks, Thomas and Prakash. Can you elaborate on the process of how it works? Can you tell me more what process you're asking about?
Let me see here.
Yeah. It went away.
Oh. Well, he can post again. Let's see.
I don't know if the audience is able to come off mute and talk to us or not, because we could do that as well.
Right. Let's see here.
The keys back and forth. Okay, sure. So let's go back and use this simple flow that we were looking at earlier.
Okay, I have.
And I think Alan might be coming on here as well. Okay.
Alan can talk if he wants now.
Cool. So Woodgrove is going to say, hey, user, I want to issue you a verified employee credential. Can you present the key against which I should issue this credential? So the user is generating their own private public key pair. The private key goes in their secure enclave, protected by their biometric or PIN on that device, and presenting the public key to the issuer, where the issuer is listing that, recognizing that public key, the DID key, as the identifier against which the credential is issued as the subject, part of the verifiable credential spec, and signing it with their own DID key. And then that signed bundle is issued over OpenID Connect to the user. The user holds it in their wallet. When it comes time to present, the user is presenting this bundle and signing with their own private key. And therefore, the verifier can verify that only this user can present this credential and no one else, because it matches the subject that's listed inside the credential, which was signed by the issuer. Therefore, no one can tamper with it. That whole bundle is what's being verified by the verifier to know, like, yeah, this is a genuine credential. It came from Woodgrove and it was issued to this user who presented it to me. Does that help?
So I noticed that you say using a biometric key. Are you assuming that they're using a key? You know, the obvious question is, you can steal a key just as easy as you can steal anything else.
Yeah, there's no defense against a $5 wrench on your head, right? But in this case, the difference is the only thing you get access to is one phone compared to all the usernames and passwords sitting in the cloud. One breach equals millions of users. Now, even if you got the key, that credential is protected by the user's biometric or PIN on that device. Assume you got the biometric and the PIN as well. At the time of presentation, you can choose to require a selfie match that says, I want to see the face of the person to whom I issued the credential. Only they can present the credential. That is not going to work. This is far safer.
So Alan, did that help?
Yeah. Yeah.
Okay.
Cool.
All right. Do we have any other questions from anyone watching? Let's see. Looking for, let's see anything in chat or Q&A is this time. Let me just mention that we have recorded this and it will be edited and put up on YouTube, on our YouTube channel. Just look for SFA ACM. We have hundreds of videos from past talks there.
Awesome.
Let's see, Q&A, something coming up.
Oh, a couple more questions. Anonymous user, did you just answer this? I think those are two different things. We can't prevent phishing so long as you are sending credentials to someone remote. You can always be subject to someone pretending to be who they are not. We are going to build a bunch of technical safeguards to go and verify the identity of the organization or the app that's requesting it. But the protocol itself doesn't do anything. That's a Microsoft value add in it. And each company will have its own ability to detect such things, right? Like Apple does it in their phone and Google does it in their browser. There's no official organization, as far as I know, how they can prevent phishing. The second question was, who hosts the public key information? Well, there are three different keys here, right? One for the issuer, one for the holder, one for the verifier. Each of those parties hosts their own private key. Their public key is public by definition. So the issuer and verifier can hold it in the hardware secure module, AWS, Google, Azure, on-premises, whatever it might be. The user holds it on their mobile device using their preferred operating system and preferred wallet app that's compatible with open standards.
Okay, I'm gonna dismiss those just to get them out of the way. Sorry.
Cool. Any other questions? You guys have my contact info. Ping me on Twitter, LinkedIn, email, whatever you prefer, or on that website. There's an email on it too. You'll reach one of us. Happy to chat. It's a new area in that sense, even though many of us have been working on it for a few years. It's just starting to become mainstream. And it will be, you'll see more everyday applications soon enough in your lives. But if you have questions or comments in the meantime, please ping us. Happy to help.
Okay, and with that, I'll say thank you. Let's see. Thank you. That is what Carl said, just said in the
Yeah, thank
chat.
you, everyone. Good chat. Thanks, Bill and Liana, for setting this up and inviting me. Have a good evening, everyone.
Well, thank you for coming and giving the talk.
No worries. Take care. Bye.
Bye-bye.